Hello, this is College Drive doing some math. Today in Algebra 2 we'll be looking at recursive rules with sequences and functions. So, just a little review. A explicit rule is a rule for a sequence that gives a sub n as a function of the term's position number. So, example, 3n minus 2. So, if we wanted to find the 20th term, we would plug 20 in, and that would give us 20, or whatever the 20th term is. A recursive rule gives you the first term, the beginning term, and an equation to tell you how it's related to prior terms. So the first term, so for example, we have the first term equals 1. And then they tell you that to find the next number, you're going to take 1 and add 5. And then to find that number, you take that number and add 5. And you keep on going and going. So if I needed to find the 20th term, I would need to know the 19th term. And to know the 19th term, I need to know the 18th term, and so on and so forth. So, first 6 terms of the sequence. Start off with the first term. And they call the beginning term a sub 0, but you can call it the first term 4. Yeah, the first term is 4. And then if you plug in 1 into the recursive equation, or the recursive rule, we'll get 3 halves times a sub 0. So a sub 1 equals 3 halves of 4. And that'll give us 6. If I wanted to find a sub 2, I'll take 3 halves of a sub 1, which will give me 3 halves of 6, which is 9. A sub 3 is 3 halves of a sub 2, which is 3 halves of 9, which is 27 halves. A sub 4 is 3 halves of the previous term, a sub 3, which is 3 halves of 27 halves, which is 81 over 4. And then lastly, a sub 5 is 3 halves of a sub 4. And this will give me around 30.375. Recursive equations for arithmetic and geometric sequence. So if you remember arithmetic, we had a common difference. You just take a number, like so if we have 1, 3, 5, 7, the common difference is that we're adding 2 each time, right? And that's just how it is with a recursive equation. If I wanted to find a sub 5, I would need to know what a sub 4 was, and then just add 2. Same thing with a geometric sequence. If I know the previous number, I'll just multiply it by the common ratio. So let's do some examples. Write a recursive rule for the sequence. Okay, so first off, we need to find out if it's arithmetic, geometric, or something else. Plus 6. So looking at differences, plus 6, and plus 6, and plus 6. So we're good. This is arithmetic. So my recursive rule is a sub n equals a n minus 1 plus d. So all I have to do is replace a sub n equals a n minus 1 plus 6. That is my rule. Part B. This is 8. This is... Nope. This would be plus 24. So plus 8 plus 24, that's not the same. 4 to 12 is times 3. 12 to 36 times 3. 36 to 108 times 3. So we're good on that. So we know that this is geometric. So a sub n equals r times the previous term. So my equation is a sub n equals 3 times the previous term. Part C. 3 to 5 is plus 2, then minus 3. That's not it. Does it look like... a sub 1 is 3. So we have plus 2, minus 3, then minus 5, then plus 2, minus 2. So the common difference are not the same. I add 2, then I minus 3, then I subtract 2. Wait. Add 2, minus 3, subtract 5, and then minus 2. So what's going on here? Alright. So this one is starting with the third term. Each next term is the difference of the two previous terms. So that one is hard to see. So 5 minus 3 gives us 2. 5 minus, or 2 minus. So you take the second term minus the first term. So 5 minus 3 is 2. Okay, and then you move on. You take the third term minus the second term. 2 minus 5 is negative 3. And then negative 3 minus 2 is negative 5. Two minus 5. Negative 3 minus 2. That one's a hard one. So the rule for this one is a sub 1 equals 3, a sub 2 equals 5, a sub n equals a sub n minus 1 minus a sub n minus 2. That's a little rough. Iteration of a function is a repeated composition of a function with itself. A repeated function, repeated composition of a function f with itself. Try iterate a function. Find the first 3 iterates of x1, x2, x3 of the function blah, when x naught is negative 2. So it means, what it means is, if I want to find x1, I need to plug in negative 2 into the equation, see what I get. So f of negative 2 equals negative 2 squared plus 3. That'll be 4 plus 3, which is 7. Now, to find x2, I'm going to plug in x1. So f of 7 equals 7 squared plus 3, which is 49 plus 3, which is 52. And then to find x3, I'm going to do f of 52, which is 52 squared plus 3, which is 2,707. So to iterate a function, you start off with a number, you plug it in, and you'll get an output, and then you put that output back into the equation to get an iteration. Molly owes $3,000 to a credit company that charges interest rate at a rate of 1.5% per month. So just to start off, we start off with, let's call this A1, our initial amount, the original amount, first term, $3,000. Pays an interest rate at 1.5% per month. At the end of the month, each month, she makes a payment of $100. Write a recursive rule for the balance of the account at the beginning of the nth month. How long will it take to pay the account? Okay. So A1 equals 3,000. And how we represent our interest rate is 1.5%. So that is 0.015 for our interest rate. Okay, and then they also tell us that the monthly payment of $100. So our current balance is equal to the rate, the interest rate, times the amount still owed, minus the monthly payment. All right. Because they have to add the interest on what is still owed, and then we're making a $100 payment at the end of each month. So we subtract 100. So this is how the equation will look. So I'm going to add a 1 to my interest rate because we're not, because they're taking, because we're adding the interest rate on, so 1.015 to the original amount. Our recursive rule is whatever that previous amount was, right? A sub n minus 1, so we start out with 3,000, and then after 3, then we add 1.5%, and then we subtract 100, and then that'll give us our new balance, and then we take that number and do the same process. So our recursive rule is that, or a recursive rule, we say A1 is 3,000, and then A sub n equals 1.015. Well, yeah, this is our recursive rule. A1 equals 3,000, A sub n equals 1.015 times the previous balance minus 100. When will the balance be 0? So when balance equals 0. Okay. So 0, because we want the balance to be 0, is equal to 1.015 times a to the n minus 1 minus 100. Okay, add 100 over, divide by 1.015, and that'll tell us 98.5 months, which is about 8.2 years. So something that would have taken 30 months, because we were only paying $100, now takes 98.5, so 3 times as much. So be wary of interest rates. And have a good day.